Section 9.1.3, we're looking at recursion formulas, which is a formula where we're reusing terms. The terms are reoccurring in the next term. So a famous one that may be familiar to you is the Fibonacci series. So another way to define a sequence is recursively. I'm looking at the definition now. Or using a recursion formula. The first few terms are listed, and the recursion formula determines the remaining terms based on the previous terms. So for example, the famous Fibonacci sequence starts with a 1, 1. Those are kind of given. And then from there, you just add the previous two numbers. So starting with the first two numbers are 1 and 1, and then for the next number, I add the previous two numbers. So 1 plus 1 gives me 2. And then the next number, I add the previous two numbers. So I take the 2 plus 1 and I get 3. And then to get the next number, I add the two numbers before that. So that's the 2 and the 3. So that's 5. And so you can see this pattern is going to be 2, 3, 5, and that just continues. And then I add the previous two numbers, I get the 5 plus the 3, and I get 8. Adding the previous two, I get 13, and so on. And I get the 21, then the 34, and then the 55, and the 89, and it goes on forever. So that's how you can get those terms for the Fibonacci sequence. So we can define that sequence generally with our a sub n's like this. So we have our we define it recursively, which means we are actually referring to previous terms. When we say an, we can't find an, or well, we find an using the term before it and the term 2 times before it. So that's how we define it recursively. So let's look at this in some examples. 41 through 47 odd is your assignment. So let's look at a couple examples from that section. Starting with 42. So with 42, we have our first number is 2. And then my next number, the rest of the numbers, is defined by finding the previous number and adding 1. So I look at the 2 and add 1. So 2, and then I start with 3. And then for the next number, I look at the previous number and add 1. So I get 4. And then I look at the previous number and add 1, and I get 5. And that's it. I just need the first 4. So that is my first 4 numbers of that sequence. Let's go on to 44. So in 44, I start with the number 2. And then my next number is going to take this. It says n plus 1 times n minus 1, which means this is the number before. So I look at the previous number, which is 2, and I add n plus 1. Okay, remember here n equals 2 here. Actually, you know what? For this one, I'm going to write my 4 blanks because I need to be able to refer to what the number n is. So I'm going to write n below the blanks. N equals 1 here, n equals 2, n equals 3, n equals 4. And then I can fill in my blanks. Okay, so I know A1 is 2 because that's where I start. And then my next one, I take n minus 1, which is 2, and I multiply it by n plus 1. Remember, n is 2, so n plus 1 is 3. And a times n minus 1 is 2. Not a times, I'm sorry, a sub n minus 1, so the previous number. So, and then for the next one, I take n plus 1, so that's 3 plus 1, which is 4, times the previous number, which is, I should figure that previous number out first. That was 6. I'll do that down here. So 4 times 6, which gives me 24. And then I plug in a 4, so n plus 1 is 5 times the previous number, which was 24. And 24 times 5 gives me 120. So there's my first 4 values of this sequence. Okay, going on number 48. So in this one I'm actually given the first two terms already. So I have 1 and 2 as my first two, and I just have to find the next two. And then I have, this says take the previous term as the denominator and the term before that as the numerator. So the next one's going to be this over this. So that's 1 over 2. And then my next term, I go 1 back to get the denominator, so that's a 1/2. And I go 2 back to get the numerator, which is a 2. So simplifying 2 divided by 1/2, sometimes that gets some a silly error type thing. So I like to think about it this way: 2 divided by 1/2, and then to multiply fractions, I flip the second and multiply. So 2 divided by 1/2 is actually 2 times 2, which is 4. So 1, 2, 1/2, and that last one is actually a 4. There. All right, and that wraps up section 9.1.3 on recursion formulas.